and 2, P1 hat 1 minus P1 hat plus P2 hat 1 minus P2 hat, and in parentheses Z alpha over 2 over the margin of error, everything squared. And the easiest one is N1, N2 when we do not have prior estimates, and we will have 0.5 Z alpha over 2 divided by E, everything squared. It's a very good question, very good point. Good. So now let's see what the problem are. Now again, I can change this to your... So I'm assuming we have to work on this problem, correct?
Yes.
Okay, so let's take a look. A physical therapist wants to determine the difference in the proportion of men and women who participate in regular sustained physical activity. So for now, I know there are two populations, men and women. I don't know which one they will consider 1, which one they will consider 2, but for now, that's all I have. So from each, that's another thing that I wanted to emphasize again and again. From each sentence, you gather some information. So the information from this, coming from this problem, from the first sentence, I have 2 groups, 2 populations and 2 samples, women and men and women. I may have the sample size or not, but this is what I know already. What sample size should be obtained if she wishes to estimate, if she wishes the estimate to be within 2 percentage points. So, which means now I write down immediately the margin of error. It says 2 percentage points. So 0.02, that's the E. Now they're telling us 99% confidence, assuming that she uses the estimates. As you know, we can never use percentages. Okay, so apparently male is the first. So P1 hat is 0.212, and that's for male. And for female, P2 hat is 0.192. And this is from the previous year, and this is part A. Now, let me copy part B because I would like to stop sharing. She does not have any prior estimates. In that case, P1 hat, P2 hat will be 0.5. Okay, so that's all I need from this. So let's work on this problem together. Men, women, this is what we have from a previous study. And you can say, what if this is wrong? Well, we will collect the sample, we'll determine the new P1 hat and P2 hat, and we can go back and use those estimates to get a better number of the sample size. Okay, so in this situation, all I have to do is plug in everything here, but I have to determine Z alpha over 2 first. Okay, so remember how we do that. This is my 99%. Of course, I have in the tails a total of 1%, but 1% divided by 2 is 0.5% and 0.5%. I cannot use percentages. So this is 0.005. In order to determine this, which is Z alpha over 2, as well as this, Z alpha over 2, of course, this one will be negative and this one will be positive because, as you know, the mean is 0. I use the inv norm in the graphing calculator with the area 0.005, mean 0, standard deviation 1, because we are talking about Z. Z is normal with mean 0 and standard deviation 1. This is carved in stone, has to be remembered forever. So now I'm going to share my screen to get to my calculator and determine that number. They're very famous numbers. But again, you don't have to memorize any of this. Okay, where are you guys? Okay, I see you. Okay, let me share my screen. Here it is. So we go to distributions once I can get there. So second in distributions. And here it is, inv norm. Yes, this is a sophisticated calculator. You don't have to use the area to the left, but not everyone has this one. So all the others use the area to the left. So yes, you can use center, right, whatever. But for everyone to be able to work with this, the area is this, and it is to the left. Mean 0, standard deviation 1, I only want to determine. Just give me the number. It's negative 2.576, famous number. We worked with it before. So negative 2.576, oh, let me stop sharing. Negative 2.576 here, and this is 2.576. Of course, it doesn't matter. I only need the positive. So for determining for part A, I only have to plug in everything. What am I plugging in? 0.212, 1 minus 0.212 plus 0.192 minus times 1 minus 0.192 times, of course, z alpha over 2, which is 2.576, divided by 2 percentage points and square. So let's plug that whole thing in the graphing calculator. I'm sharing my screen. So parentheses, outside parentheses, 0.212, another parenthesis, 1 minus 0.212, close, plus the other one, 0.192 times, parentheses, 1 minus 0.192. Yes, I could find this difference, but I want you to see the formula. Don't forget another set of parentheses. So left parenthesis and right parenthesis. Now, times. In parentheses, I have the top, which is 2.576. I have the denominator, which is 0.002. This quantity has to be in parentheses because it has to be squared. And when I press enter, I get this humongous number. Even if this is 0.8, I still have to go up. This is not the way we round numbers. If this number is under 5, I don't change this, right? But it doesn't matter when we determine the sample size in order to guarantee the margin of error of 0.02 or less. No matter what I have here, unless everything is 0, then I don't change anything. But whatever I have, even if it's 1 or 2 or 4, or 10, I mean not 10, 9, I still have to increase the 8 to 9. So the sample size in part A is 534.499. Now for part B, that's for part A. Any questions so far before we move on to part B?
I have a question.
Yes?
Where did you get the margin of error, the 0.02?
Let's take a look. Maybe I made an error. What sample size should be obtained if she wishes to estimate the estimate to be within 2 percentage points?
Okay. Thank you.
You're welcome. I'm always glad to go back and check. Other questions before we continue? Okay, so now for part B, the formula is much easier. For part B, the sample size will simply be 0.5 multiplied by 2.576 divided by the margin of error of 2% squared. So 0.5 when we do not have an estimate, and 2.576 divided by 2 percentage points and squared. And that's it. 829,472. This is the time in which we do not round up, because there is nothing else. If it were 0.01, I would have had to increase 2 to 3. Why? To ensure this. If you change this to 471, the margin of error will be bigger. But if I increase the 9.8 to 9, the margin of error will be 2 percentage point or less. Guaranteed. Very good question. Preston, is this better now?
Yes. Still, it sounds like a lot, but I definitely got it now.
Okay, there are just two formulas to plug in, but you have to be very careful how you plug it in the graphing calculator because it may give who knows what if you don't have enough parentheses. So obviously, this is the key. So you either determine this, which I don't recommend, let the calculator do that for you. You need parentheses here. If you omit these parentheses, you're not going to get the correct answer. If you omit, not you, I'm saying if we, everyone, if we omit these parentheses, we're not going to get the correct answer. Okay, so these are absolutely mandatory. Good, next question. Is there anything else we need to address from anything you tried? And thank you, I saw that many of you, not everyone, but many of you pleased me by getting to chapter 11. Thank you. Anything else, or we go back to finish up the other problems?
I have one more question about this problem.
I'm ready.
Where did you get the z alpha over 2 over the margin of error, like the z alpha? Oh, okay. I see. Thank you.
You're welcome. Anyone else? Anyone else other questions on this or anything else? Did you work?
Good.
Okay, did you work on anything else that you would like to address?
That was my only question.
Thank you. Anyone else other questions? Okay, in that case, yeah, yes, I saw. Sorry about that. Thank you for your patience. There must be some conspiracy theory here going on. Just kidding, of course. Okay, I'm sharing my screen to go back to, I think we had 3 problems left from here. I think the last 3. Do we still need them? If you say yes, we'll look at them. There were the last 3 that we did not get to last time. 10, 11, and 12.
Can we do this?
Yes? I just didn't hear you. Yes?
Yes.
Okay. So did you have difficulties with anything else before we look at 10, 11, and 12? Did you have any other questions here? Okay,
No,
then.
I don't.
Okay. Well, let me know. You can stop me anytime. I think we didn't do this one. I know there was one where StatCrunch was not available. Yeah, it could be this one. I'm not sure. Yeah, I think we did this one. I can look at my notes from last time because I write something for every problem. 26. Yeah, I thought that the one with the temperatures we did together. I'm pretty sure, but we can do it again. Okay, so we are on problem, what is it? Problem 10. Okay. Who would like to start or help with this one? Anyone?
I'll read it.
Thank you.
A study was done on body temperatures of men and women. The results are shown in the table. Assume that the 2 samples are independent simple random samples selected from normally distributed population.
Mm-hmm.
And do not assume that the population standard deviations are equal.
Right, which means we don't have to do the pooled. We never did that anyway. Complete parts A and B. Okay. So Now here it says use a 0.05 significance level, that's alpha, to test the claim that men have higher mean body temperatures or temperature than women. And in the meantime, I'm going to copy the data. What do you think?
See?
Very good. Awesome. C it is. Everyone agrees with C? Everyone?
Yes.
Thank you.
Yes.
97.68. I'm copying 97.42, 0.82, 0.68. So I don't have to go back to it. Good. Well done. Find the test statistic. Okay. So for the test statistic, this is a test statistic for two means. Stats, tests, we have to look for two sample t-test. That is for means. Otherwise, he would have said proportion, and it's a z-test. So two sample t-tests, so this is number 4. And we have the statistics. We don't have the data listed in list L1, list L2. So x1, 97.68. Standard deviation, 0.82. And 1, 11. X2, 97.42. I remember this vividly, and I think we rejected. It appears to be the same. Okay, so mu1 greater than mu2. Okay. And as you know, I like to draw, because I always like to draw that curve. Ah. I had graphed something with my other classes. It was a scatter plot. Good. So I see that the test statistic, T statistic, is, and the p-value is huge p-value. So 0.9901, and the p-value, a lot of shading in there, 0.1703. Good. Back to the problem. T statistic. They want to round to 2 decimal places, then just 0.99. And the p-value, 3 decimal places, 0.170. 17 is good enough. Okay, so now let's draw a conclusion. Remember, alpha is given to us 0.05. So alpha equals 0.05. Let's draw the conclusion. This is the p-value, and this is the alpha, level of significance. So what happens to the null hypothesis? Remember, the null hypothesis mu1 equals mu2, and the alternative mu1 greater than mu2.
Fail to reject.
So we fail to reject because the p-value, thank you very much, is it V, greater than alpha. Every time the p-value is greater than alpha, the test statistic falls in the non-rejection region. Fail to reject. The null hypothesis. That means there is insufficient evidence. So let's look for that. Which one?
Is it D?
Yes, of course. C, right? Fail to reject. I'm sorry. Fail to reject. There is not sufficient evidence to support. Of course. Yes. Yes. Of course. Good.